Good morning. This is a presentation by Lucid Technologies. I'm Suren, and I'm a principal architect who works here on the integration side of Collibra. This is a presentation of a conceptual prototype which we have created, and this is basically for data provisioning and to solve certain issues that data scientists and enterprises have in getting access to data and being able to access data. And we would like to demonstrate as a concept how this can be done entirely using various components of the Collibra platform and entirely driven by metadata. So let's go into a presentation, and at the end of this presentation I'll be showing you a short demonstration of how the solution works. We start with a data scientist, and she is essentially looking for data. She knows what data she wants, and she knows that it needs to go to the data lake. And she is not sure how to get it where it resides. This is where somebody who can enable data discovery enters into the picture, and this person knows where the data resides, where it needs to go to. He or she also knows what additional tasks need to be performed on the data before this data can be entirely provisioned to the target space. But what they cannot do is to actually get this done without intervention from IT people for development activities. So this is where the Collibra platform steps in, where we ingest metadata about the source and we build metadata about the target using the Collibra catalog and the Collibra uh, operating model. Next, the source and target are mapped to each other, and transformation rules are designed in the core Collibra DGC platform. After this is done, the Collibra Connect platform helps provision data from the source into the target. Let us now take a look at the detailed lower level components that enable this entire process. We start with the data scientist, the data enabler, and we start with both of them having access to a Collibra server. The source, for the purposes of this demo, has been defined as an Oracle relational database instance, and the target where the source data needs to finally reside is a Hadoop data lake, and for the purposes of this demo, we have utilized a Hortonworks data lake. It starts with the data scientist requesting data depending upon what data she needs. Next, the uh, data enabler uses the Collibra catalog to pull in metadata about the data which is in the source and assembles a data set. Next, the data enabler builds a mapping between the source and the target to show where the data currently resides and where it needs to go to, and also defines the transformation rules in the form of microservices. So the data enabler now, after defining the source and the target columns and tables or files, uh, applies microservice depending upon what are the characteristics of the particular source and the target. Next, the data enabler makes a request to publish to the data lake. This request comes into the Collibra gateway, into Collibra Connect, and here a mule flow first reads the mapping out of the source Collibra server, then dynamically builds a SQL based on the source information, that is the host where the source data resides, as well as the database where the source data resides. Connection string, a JDBC connection string, is dynamically built out, and SQL is built out for retrieving data, and the data is then retrieved and read out of the relational database. Next, a microservice has been applied to mask whatever data is personally identifiable information. After this masking, the data is then published to a data lake, which is HDFS data lake, and this is done using the HDFS connector. After that, the data scientist is automatically notified. Let us now go in and see what this actually looks like when it is implemented. Here we have a mapping specification. So the source uh, list of source data, the customer data is the table where it resides, and the field maps have been defined here, and the source columns have been pulled in using the uh, Collibra catalog product. And next, target data structure, which is a target data uh, um, target file, which is in the JSON format, has been defined here as part of the mapping, and target columns have been identified in the target data structure, and field maps define the source to the target. Now, if you look at how the customer data has been defined, the customer data table consists is from part of a schema, and this schema is part of a database, and this database is in a particular host. So basically, using the host, database, and schema, you will be able to build the data connection, JDBC data connection easily. And using this mapping, which says what are the sources, you can build the query for extracting the data. Next, the target file. As we can see here, the target file, we saw all the fields of the target file which have been defined. And here we specified which directory it needs to reside in. And in the location attribute of the directory, we also specify which Hortonworks host it needs to reside in. As we can see in Ambari here, this is the Hortonworks host that it needs to reside in. And this particular directory is empty at this point in time. Let us now look at what the source looks like. The source is a database table, and it has got all of this information in city, country, customer name, the social security number, and there is also a attribute called profit per customer which needs to be pulled in. Let us now go back and look at how this transformation and load happens. Now, if you look here, there is a particular column called SSN, which is nothing but the social security number. And this social security number, as you can see here, has been tagged as personally identifiable data, and it has also been tagged as with a need to be masked. And if you look at the microservice that we have attached here as part of the field map, you can see that the microservice for anonymization has been applied. Now that we have defined the source, target, specified field maps, written up the transformation logic, and applied the microservice, we can now go ahead and actually publish this to HDFS. The job is getting called here, and based on this, the HDFS instance is being invoked. Let's now go back into Ambari and see what has happened to the directory. As we can see, we have a file called customerdata.json. Let's now download this file and open it up here. And if we format it properly, we can see that the profit per customer, customer name, city have been brought in as is, but the social security number has been masked, and the tags for the social security number have also been passed on into the data lake. So since this has been passed on into the data lake, it is the tags and the attributes of the data item continue on into the data lake for further use. Now, it's not necessary that the ETL, that is the extraction, transformation, and load, necessarily has to happen through Collibra Connect. It can happen using the metadata, and it can happen on any other platform. It could be AWS Glue, it could be Scoop, it could be a traditional ETL tool such as Informatica or DataStage or Talent. The key components are the metadata, which is the JDBC connection or the connection to the host and the database, the query that is required to extract data out, and this target file and the target location and the microservices that need to be applied. All of these are just metadata, and using this metadata, any ETL tool or any other component such as AWS Glue or Scoop or Uzi, any of them can easily apply this. And in the case of traditional HDFS products, you can also have pig Latin scripts which are dynamically reading this information out of the Collibra Connect platform and building services and building extraction, transformation, load routines dynamically. So that's basically the end of our presentation. Thank you for listening so far.